This is a simple operational sequencing circuit. The manual valve controls the double-acting cylinder. The double-acting cylinder in turn will strike the mechanically operated two-position DCV, which in turn sends oil to the motor to run. The way you read the circuit is you push in on the lever, port P sends oil to actuator port A, entering the cap end of the cylinder, causing the cylinder to extend. The oil leaving the cylinder from the rod end will be at that moment directed back to tank. So the cylinder extends the cam on the cylinder, strikes the roller that's on the cam valve. The cam valve then is actuated, meaning that the top block is pushed into position and fluid from port P goes out through actuator port A, and then the motor begins to run. If I pull out on the DCV lever, then the flow is reversed. Now the cylinder retracts. Once the cam walks off the roller wheel, the mechanical DCV returns to its normal position, which is the lower envelope as illustrated by the spring. Anyway, when it returns to its normal position, flow going to the motor is interrupted and the motor stops running. Since there is no back pressure on the motor just simply comes to a smooth stop. However, in this kind of a circuit, because that motor does have a flywheel, you may hear a noise in this line. If you do, it's cavitation. This is the pneumatic equivalent of the circuit you built hydraulically on page 107. You have two DCVs, one manually operated on the left, the one on the right closest to the actuator is pilot operated. Air is supplied to the manual DCV, and then from the manual DCV it is sent through the pilot lines to the pilot operated DCV, which in turn controls the actuator. The actuator is set to extend with restricted flow on the rod end. This is meter outflow control, so if we adjust the flow control to where there's some resistance, we will see that the cylinder will extend slowly but retract quickly. The pressure on gauge A will vary with restriction at the flow control valve. Okay, so the way that the circuit is drawn is the normal position. So if you look at your air line running through the pilot operated DCV, that line goes from port 1 through the DCV. It generally will leave either through port 2 or port 4 on most valves. From there it goes to the rod end, and notice the position of the check valve. When air is moving in that direction, it goes over the check valve. So that's why I said it would extend slowly but retract quickly. Now, the cylinder is normally retracted. To get the cylinder to extend, we have to send air through the lower pilot operated line or pilot line, and that causes the lower envelope in the pilot operated DCV to move upward, reversing the flow path, sending air into the cap end, while air from the rod end would be exhausted to the atmosphere. If you look at the arrowheads in the blocks on the DCV symbol, you'll notice which pilot line it takes to cause the shift. So the pilot line that's connected to the block, when it is energized, that is the block that you get. So in order to extend the cylinder, we need the block on the bottom. So if you go back to the manual DCV, what we need is to push in on the lever. That causes a connection to be made between the pressure port and the lower actuator port. Alright, that port sends air through the pilot operated line, the pilot line, to the pilot operator on the lower end of the pilot operated DCV. We get that block and that flow path, and that's what causes the cylinder to extend. Then if you pull out on the manual valve, you get the opposite. The upper pilot line is energized, causing that block to move into the operating position, and then air enters into the rod end of the cylinder for it to retract. Once again, this cylinder should extend slowly and retract quickly. In part 8, we're we're going to observe the operation of a pneumatic single pilot operated DCV. Now, in the circuit there are two DCVs. This diagram appears in your lab manual on page 110. So what we have are two two-position DCVs. The one on the left is manually operated and has 3 flow paths. If we push down on it, then air is connected under pressure between ports 1 and 2, port 2 connected to the pilot line leading to the two-position 4-way pilot operated DCV on the right hand side, right beside the actuator. When that happens, air will flow through port P and out of port B into the cap in. The cylinder extends slowly. We have the same meter out type flow control as we did in the previous diagram. And then it will remain extended as long as the valve on the left has its operator pushed in. If we release that operator, I'm talking about the valve on the left right now, if we release the operator, the spring pushes it back to the normal position. Air from the pilot line is exhausted to the atmosphere. The spring in the other DCV pushes it back to the normal position, which sends air to the rod end of the cylinder, and the cylinder retracts. There is no intermediate capability of the circuit. That cylinder can be extended, it can be retracted, but it cannot be stopped in the middle of its travel. And again, the pressure on gauge A is determined by the amount of restriction at the flow control. Part 9 is the pneumatic equivalent to Part 6, found on page 108. In this circuit, we have a double-acting cylinder controlled by a two-position 4-way manually operated DCV. The exception is this DCV does not have a spring operator in it. It has what is known as a detent. If you look to the right of the symbol, that emblem indicates that that valve is momentarily blocked in either position wherever the operator shifts it. As we see it drawn, it's in its normal position, and as it's drawn, air is going from the pressure passage to actuator port B, entering the cap end, causing the cylinder to extend. When the cylinder extends, it strikes the cam valve on the two-position 3-way DCV, and this in turn causes the motor to run. If I pull out on the lever, then the cylinder retracts, the cam is released from the roller on the mechanically operated DCV, flow to the motor stops, and the motor stops running. Part 10 on page 112 demonstrates the basic operation of a shuttle valve. There are two valves that use the schematic symbol that we see in the middle of this drawing. One is a shuttle valve, and the other that looks close is a quick release valve. The quick release valve always has a pilot line, so we don't see that here. This is a shuttle valve. The operation of this circuit is a little bit tricky. If you look at the valve on the left, I push in on the lever, air is sent into the shuttle valve, pushing the movable member to the opposite side, causing it to seal. So then air moves out of the shuttle valve in the middle at the top, through gauge A, through the flow control, and into the single acting cylinder, extending it. If I release that lever, since the movable member is always will be on the right hand side, and we have a block center DCV, air is trapped and that cylinder remains extended. If I pull up on the lever of the manual valve on the left, since the internal movable member is already seated on the right, the single acting cylinder will not retract. So what is required is that I lift up on the lever on the manual valve to the left and push on the lever on the 2-position 3-way valve on the bottom. This causes a pressure differential to occur, which causes the movable member to move from right back to left, and then a pathway through the lower valve, the 3-way valve, is now completed for air to move out of the cylinder and out into the atmosphere. The cylinder is aided in its return by a spring. So this is a run through of lab experiment 11. I've already sent out the answers to the questions. Any other question regarding this experiment should be directed to me through the email, and I hope that this explanation, this run through, has been of use to you. It would be a lot better if we could put our hands on the equipment, but that's not possible right now. So this is about the best that I can do. I'd considered making some videos, but they will not allow us onto the campus right now, at least not without going through a pretty big hassle. So this is the best I can do for right now. Like I said, if you have any questions, please email me and I'll be more than happy to answer your questions.